Hi, my name is Ken Lassison. I wrote a microbiome prescription website. And what I want to do today is talk about an interesting little unexpected discovery which showed up in my work this week. And to give a quick background, there is in statistics in AI a method called binary logistic regression, and I was applying that to the data which are being uploaded by a variety of people. Now, the result of which is I could calculate odds, the odds of a bacteria being associated with brain fog, the odds of bacteria being associated with constipation. But because I'm also making use of data from the Kyoto Encyclopedia of Genome Genomics, I can also calculate the net compounds being produced or consumed, as well as the enzymes. All of that comes from the bacteria. So basically, we're doing almost like a DNA study of each one of the bacteria and getting all of the magnificently complex details and putting them together, turning them around and around and around in terms of software programming, as in talk about some high CPUs for many weeks, and to calculate the odds. Now, after I calculate the odds, I decided to do a sanity check. So what I did was calculate the odds for different bacterial associations, how often they occur, and what I got was a bell curve. Okay, that is basically what I would expect to happen. It's sort of very, excuse the expression, natural. So that was good. Okay, no problem. Then I went on and did for compounds. And basically the same thing. You see a little bit, the peak is on the right instead of the left. So here, in other words, a positive odds means that having too much is causing the problem. A negative odds means roughly not having enough causes the problem. And compounds are the same thing. Excuse my typo. So what we have is having too much of some compounds seems to be causing the problem there. But again, it's a bell curve. But then the shocker showed up. Enzymes. Wait, what? That's not a bell curve. That's extremely skewed. And it leads to a very interesting conclusion or hypothesis. And that is that the reason that most of the symptoms shows up is because of deficiency of enzymes. In other words, okay, so that is the cause. You don't have enough enzymes in your microbiome bacteria collection to be a balanced person. You have a bunch of symptoms showing up. Okay, my original hypothesis was it was connected to bacteria, or perhaps connected to compounds. There's some connections, yes, but this one blew me away because the degree of it is so large. Now, here comes the bit of fun. The problem is you walk into a health food store and ask for a list of, and I can give you the list of the enzymes. In some cases, there are dozens of them. And you can go and look at some very blank faces because they will have no idea what you're talking about. Because enzymes are, especially the wide variety, we're talking about 2,500 different enzymes, are simply not available at the retail layer. However, those enzymes are also being produced by the bacteria in some probiotics. Hence, if I know what enzymes one is deficient in, if one knows what bacteria are in different probiotics, you can then go and figure out which probiotics will compensate for the missing enzymes. So, a little bit of mathematical magic, and I ended up creating a page. This is a summary page. The link is right here. And what you will do is you have high and low odds. This is mainly a high-level overview of where one should go for a particular symptom. Particular symptoms, the bacteria association, the lowest is one, the highest that one. 941 is not to be concerned. Basically, it means that the statistical method did not reach a final number in reasonable time. So that's basically saying, okay, that's it. I've done enough. 941 is a magic number. So the ones which are negative are the ones that are too low on high. Again, that number is only going to be useful if you are working with actual samples. The compound, same thing. And then we have the enzymes over here. And some are big negative and some are small negative. So all you have to do is click on one of them and you go through and voila. It's ranked order and gives you the name of retail available probiotics. Not just telling you, okay, you need just a particular species. Here are actual probiotics. And it gives you the weight in terms of the impact. In some cases, there would be major differences between the top and the bottom of the list. And this, I tossed you back the top 100 out of 250 probiotics. So you have a comprehensive list. The number of species which are in the probiotic and the enzyme name. In general, what you want is you want a good weight and you want a low species count as the preferred one to start with. So you ideally will go and get one bottle of just one. Then you would go and use the bottle up, taking it daily until it's done. And then you go up and you go and move up to something else which has more species to it. And you try that for, again, one bottle. Now, how long will a bottle last? It will not or should not be working off the dosages on the bottle. What you should be doing is going over and working on the dosages used in effective clinical trials. So if you click here, you will go over there, and now you can go in and just search for example, lactobacillus, and here are the ones. So one of the items I think was glycerate. So you just click here, and there's one study, and so it's basically you should be taking 10 billion community forming units per day, every day. The bottles may be providing you only with 10 million CFC, so you'll be taking 100 capsules literally of some bottles. Again, you need to sit down, look at how many CFUs are in the bottle. A lot of probiotics are up in the dosages to be a higher number. Generally, it doesn't cost, most of the cost of the probiotic is the bottling and the capsules and the mock-ups. So increasing from 100 million to 1 billion MCFUs may cost the provider per bottle $1 or $2, and that's it. 10 times more, $2 more, it makes sense. So be smart in your shopping to find ones which have the high CFU values to it. Okay, so now turning the page, that's basically it. I will go and go into more details about how these odds are calculated. It's a nerdy subject. It is a lot of stuff. Bottom line is I'm trying to model and exploit all the information we have because we don't have enough information. It turns out that there is enough, there's interesting information that could potentially apply and which we could use to model. Whether or not the modeling gives correct clinical results, we don't know. But I'd rather use a mathematical model based on hard clinical data like genes and genomics in an actual bacteria, which is about as hard as you can get, to work from that rather than waiting for a clinical study to happen, which could be 3 decades from now. I'm going to be bye-bye by then. Or alternatively, going on hearsay, in which case it's pretty random whether or not it's effective or not. You can hope it is. But often people go on hearsay because they're being disappointed by MDs not being able to actually provide information. And why? Well, the reason is pretty simple. When you go over and you take a look at the details, the information gets overwhelming. Let's just go back to the symptom summary page. So here we have there, you notice here we have a blank. That means there are no associations which found with compounds which connected with joint redness. We do find that, oh, this is interesting, is that the low number is a positive number, usually a negative. And what that means is that joint redness is associated with high bacteria counts, and only high bacteria counts. In other words, the only way you can deal with it is to reduce the bacteria. Click View, and we see all the items, and there you go, and we have 2100 ones, all which are associated. 941 to me is a little bit of a dilemma because it means the calculations basically gave up because it wasn't able to do anything. So I usually try to avoid those. And let's go over to flu-like symptoms. And we have the same problem. Same problem. Okay, and this is dealing with compounds. Oh, this is dealing with bacteria, and I can understand it. I think I know how to fix it. So these numbers may be corrected. The problem is that if you take a look at any particular one, let's click on one here to get over to the chart, and you see exactly why we get 941. We have 83 people who have this particular thing, and one keyword, one person who has it. Hence, it's basically saying throw up my hands and says, excuse me, I don't know what is going on. You don't have enough data, you don't have enough samples of it where they have the symptoms there. One could assume that because you have it, you can't really do that much. And what I need to do is exclude the 941 from the list, just because it is a single thing. We don't have enough data. The interesting thing is we have a large number of people with the symptoms, but it is very rare that somebody with this symptom has this bacteria, which would imply that you want to get rid of this bacteria would help you. But again, this is another level of interpretation. I just wanted to walk through the 941 odds. If you go to another one up here, I'm just doing this for the sake of illustration. Oh, 941, and we have 0 here. So I need to exclude again. Oh, I mean, in one way, it is very clear. We have 31 people who don't have the symptom, and no one has it, so that if you have this one, you really probably want to have this bacteria, I'm sure you want, but again, 941 is the software throwing up a hand saying, I have no idea what to do. So I will go in and take care of that issue momentarily, and at this point in time, I'll shut up and let you go and play with the site.